It's important to understand that in a SureServo 2 drive, STO disables the output stage to the motor, so the motor has no power, which means it can't produce any torque. It's the fastest and safest way to remove power from the motor. For example, if you turn off power to the drive in an attempt to power down the motor, which you should never do by the way, the drive will continue to try and execute whatever command it's running until the power is completely gone. That takes time, and it can cause all kinds of havoc inside the drive and unpredictable motor behavior. So, if you need to disable the motor as fast and safe as possible, then STO is the option you want because it will immediately shut down the power to the motor completely independent of anything that's going on inside the drive. And it won't harm the drive or send the motor off doing weird things. Hence the name, Safe Torque Off. But there is a downside. Once STO is activated, the drive no longer has control over the motor and the motor is left to free spin down. If it has a lot of inertia, or the load has external forces keeping the shaft spinning such as gravity pulling on the load, well, that could take a while, which could be dangerous in some applications. So it's up to you to decide if STO is appropriate for your application. The drive comes with this connector pre-wired to bypass STO, which is great if you're bench testing or you don't plan to use STO in your application. The connector is pre-wired like this, where pins 1 and 2 simply provide the signaling needed to turn on the opto isolators, which tells the drive everything's okay. To use STO, remove the jumper wires from the CN10 connector and wire the connector to the safety relay. I'm using this dual channel safety relay from AutomationDirect.com. Dual channel means you can have dual safety inputs like this, where one switch provides 2 contacts to the safety relay for redundancy. Those contacts can come from any safety device, like a safety limit switch, a safety pull cable, a trap key system, interlock switches, etc. We'll just use a simple dual contact e-stop push button for this video. This is the part number of the one I'm using, but it only comes with 1 contact, so the extra contact part number is this. Let's take a minute to understand how the safety relay works. It'll give you a better appreciation for why safety relays are so important. When the e-stop button is wired like this, and configured for cross-fault detection, the safety relay sends a known voltage pulse out S11 and looks for that on S12. It also sends a different voltage pulse out on S21 and expects to see that on S22. So if it doesn't get one of those pulses, it knows that contact's open, and if the wrong pulse is received, it knows it's miswired. So the safety relay is continuously monitoring that the safety wiring is correct and that it's operating correctly. That ensures that it's actually going to work when you need it. As long as there's power to the safety relay, the e-stop is not active, and the drive shorts these 2 pins to tell the relay everything's okay, then these contacts will be closed, which allows power to flow into these opto isolators, which allows power to go out to the motor. If the safety relay loses power, or either of these e-stop contacts opens, then these guys open, and the drive cuts off power to the motor. And remember, the drive totally cuts power to the motor, leaving it to free spin down by itself. There are no options for the drive to provide a controlled stop when using STO. When the drive sees STO is activated, it shorts these 2 pins to tell the safety relay it got the message and it did something about it. The safety relay won't allow these relays to close and pass power again until it gets that feedback. When the e-stop switch is restored and it sees that the drive has acknowledged that it got the STO signal, the relay resets automatically if configured for automatic reset. That closes these contacts. And when the drive sees the STO condition go away, it automatically clears the acknowledgement, so the relay will need to see another acknowledgement when the next STO occurs. The drive won't allow the motor to run until it sees the alarm reset toggle after the STO condition is cleared. Now that's important. A proper e-stop requires 2 actions to clear it. Well, hopefully you can see why these safety relays are so important. They continuously verify all the safety circuitry is functional to ensure that it will work when you need it. And they monitor the status of the STO function and won't let you reset the safety circuit until the drive acknowledges it got the STO request. Let's do an example. I'm using the exact same hardware as the quick start video, except this STO jumper is replaced with a safety relay, and I added a 4.5-pound steel pulley to give us some inertia. This is my STO e-stop button that will trigger the safety relay. And this is the normally open alarm reset button, which defaults to digital input 5. The top LED tells us the relay has power. The bottom two are lit, which tells us both of these are closed and passing power. So if either of these LEDs are off, something's wrong. I factory reset the drive so you know exactly where I'm starting from. Switch to speed mode and power cycle the drive. Please, don't forget to power cycle the drive after a mode change. If things don't work, it's usually because you forgot to do this. I know because I do it all the time and it drives me nuts trying to figure out why I can't get the motor to spin. We need to set up the safety relay to match all of this. There are two switches inside the cover, which has a little setup guide printed on the inside. Switch 1 tells the relay we've wired it to detect cross faults. Switch 2 configures how the relay will restart when the e-stop button is released. We're using the up position to tell the relay to automatically restart when it sees the e-stop is released and the drive is shorted to 2 pins. Let me put that cover back, and I'll enable the motor and increase the speed. If we hit the STO e-stop, sure enough, we see the relay's LEDs turn off, the STO alarm appears in the display, and the motor's just left to free spin its inertia down on its own. Again, once STO is activated, the drive no longer has control of the motor. Remember, when the drive saw the STO condition, it automatically reported that back to the relay by shorting these pins. So when I release the e-stop, the relay automatically resets itself because we configured it to automatically look for those shorted pins. And that releases the STO condition. The drive sees that the STO condition has been released, so it automatically releases the feedback so the relay is ready for another cycle. I then hit the drive's alarm reset button to tell the drive it's okay to apply power to the motor. Perfect. And again, STO kills the power to the motor quickly and safely, completely independent of anything else that's going on inside the drive, so it works no matter what mode the drive is in. Well, that's it. And while I did a lot of explaining in this video, all we really did to get STO working was wire up a safety relay and set the 2 switches on the safety relay, telling it how we wired it up. Not bad at all. Hopefully, now you have a better understanding of how STO works and why you'd want to use it. It's not for every application, but when you do need it, how cool is it that the SureServo 2 drive has it built in, makes it super easy to use, and has that configurable feedback signal so you can use it with just about any safety relay or any safety application. You just add a safety relay. No need for external contactors or other devices. That saves you time, space in your cabinet, and money. Click here to learn more about the SureServo 2 system. Click here to subscribe to our YouTube channel so you'll be notified when we publish new videos, and click here to learn about Automation Direct's free award-winning support options.